All right, in this section, we're going to take a look at half reactions. Balanced redox reactions, which we were looking at in the previous section, can also be written as a pair of half reactions. Each half reaction shows the gain or loss of electrons by the species that are reduced or oxidized. The electrons themselves are shown in half reactions. The only species that gain or lose electrons are shown in half reactions. So if there are any species that are not oxidized or not reduced, like maybe if we have oxygen or hydrogen that doesn't change from reactant to product, then we wouldn't show that in a half reaction. For example, this reaction that we've seen before between copper and silver can be written as two reactions showing the gain and loss of electrons by copper and silver. What I've done is I've broken up the two processes into two separate ones, where copper 2+ gains 2 electrons to become copper solid. Gain of electrons here is reduction, and the silver 2Ag solid produces these 2 silver ions and a loss of 2 electrons, which is oxidation. If you combine these two half reactions together, then the electrons will cancel out because you'd have them both on the product and the reactant side, and you get the full reaction. Half reactions require that the electrons and the species are balanced. So in this case, we have 1 copper on both sides. This copper has 2 positives. In order to make sure that we end up with something that's neutral, we have to also have these 2 negatives or electrons as reactants. The same on the other side. If we have 2 positive silver ions, we've also got to have these 2 negative electrons to get an overall 0 charge. So when writing half reactions from a full reaction, the first step is to balance the full reaction. Half reactions are a good way to ensure that all of the electrons are accounted for. This will be especially valuable in a later unit on electrochemistry. Here's an example. Write half reactions for this full reaction which we balanced earlier. So if I take this 2 aluminum solid and I produce 2 aluminum 3+ ions. Notice that on the right-hand side, we have a +6 charge overall, 2 times +3. And on the left, we have no charge at all. So in order to balance that, I need to put 6 electrons on the product side. My other half reaction looks like this. 3Fe2+ produces 3Fe solid. Again, on the left-hand side here, we have an overall +6 charge. 3 times 2+ give us +6 overall. So we need to combine that with 6 electrons to get an overall neutral half reaction on both the left and the right. And you can see in this case that the number of electrons lost, 6, is equal to the number of electrons gained. So let's look on the next page for a summary of that. Okay, looks exactly like what we did on the previous slide.